Hello friends, a warm greetings and welcome to my YouTube channel. First of all, I thank you for taking your valuable time and interest in this water quality data based tutorial. In this video, we will be learning the systematic and correct way of entering the water quality analytical data into SPSS software. The quick questions that might cross your mind right away is question number one. What is the purpose of entering the water quality analytical data into SPSS software? The answer is to enable the researchers to perform any desirable inferential statistical analysis that his or her study requires. Now, for the researcher to be able to perform any inferential statistical analysis in SPSS, the basic and first requirement is the water quality analytical data. That is the data which was obtained after the water samples have been analyzed in the laboratory. So in order to obtain this data, for smooth explanation and understanding, let us use a hypothetical or an imaginary study. Let us assume that I am interested in monitoring the quality of groundwater found in selected study area. And from this selected area of study, let us assume that three different sources of groundwater were randomly selected as sampling station for the study. And the duration of the study is for a period of 2 years. And let's say the study was carried out in the year 2018 and 2019. And the seasons selected for the study were winter season and monsoon season. Water samples for different sampling station and season of samplings were collected and analyzed for various water physico-chemical parameters such as pH, dissolved oxygen, biological oxygen demand, total hardness, calcium, magnesium, conductivity, total dissolved solids, and turbidity. These different water parameters selected for the study will be analyzed in the laboratory, adopting the standard protocol of analysis as given by AFA or MIT. Once these water samples have been analyzed, then the data required will be obtained. Now, let us assume that these data displayed on the Excel sheet are the water quality data obtained from our hypothetical study. For easy identification and visual from your end during the demo, let us assume that the data displayed in blue are the mean value of different selected water parameters from three different sampling stations of the year 2018, where these data are the data for the winter seasons. These data are for the monsoon season. Similarly, let us assume that the data displayed in red are the mean values of selected water parameters from three different sampling stations for the year 2019. These data are for winter season and these are the data for the monsoon season of the year 2019. Next, once you have the water quality analytical data, then the next stage is what are you going to do with the water quality analytical data? Therefore, for that, there are two options or ways in which the data can be used in order to generate the desired information about the water quality. First options, the analytical data obtained from the analysis of the water samples are presented either in a tabular form or graphically. This style of format of data representation is done technically adopting what is known as a descriptive statistics. However, there's a second option. If the researcher wished to further extrapolate the data and draw more inferences about the population based on the data collected from the samples, then the data must undergo various statistical analysis of interest such as ANOVA, t-test, z-test, finding the F and P values, correlation analysis, regression analysis, and many more. It depends on the requirement of the study. These different statistical analyses are cumulatively referred to as an inferential statistics. In order to carry out or perform any inferential statistics analysis, a software called Statistical Package for Social Science, or in short SPSS, is used. SPSS is one of the most widely used statistical package in research. With this basic background information, we'll now move on to the next stage. That is, we will learn the different steps involved before entering the water analytical data into SPSS. And the first step is the arrangement of the water analytical data in Microsoft Excel sheet. Practically, it is always convenient and easy if the analytical data are first properly entered or arranged in Microsoft Excel sheet. I believe you are aware that Microsoft Excel sheet is the most convenient platform to carry out any calculation if you have n number of sampling station and x number of parameters studied in any water analytical study. To start this step, first open the Excel sheet that contain the analytical data of water samples collected from different sampling stations and seasons and year of sampling. For systematic arrangement of the data, first thing first is arrange the different variables used in our hypothetical study in Excel sheet, starting with year, season of sampling, sampling stations, replicates, and the selected water parameters one by one. Now you might be asking why replicate is included. It is because for every single water parameters, in order to obtain a single mean value, three analyses were repeated because the average of the three replicates will constitute the mean value of any parameters. That's why we have R1, R2 and R3. After which, another important point to take into careful consideration is checking out the number of cells required throughout the study period or the number of cells required per year. So to obtain these data, let's use the simple calculation and remember this calculation is based on our hypothetical study and this number will change in case if your study is different. So first, what is the duration of our study? Hypothetical study is for 2 years, which is 2018 and 2019. So just make the cell list as 2. How many seasons? Study was carried out for 2 seasons in a year, and that is winter season and monsoon season. So the value here will be 2. And sampling station. So we have 3 sampling stations selected for collecting the water samples for the analysis. So here we'll keep as 3. So for each parameters we have 3 replicates R1, R2 and R3. So we'll keep as this as 3. So now how many number of cells we will require throughout the study period and how many number of cells we require per year. For calculation throughout the year, you just have to do is give an equal sign, 2 into 2 into 3 into 3. So this will give you 36. So which means that you require 36 number of cells throughout the study period. And per year it will be equals to throughout the year divided by duration of studies for 2 years. So we have to divide by 2. So number of cells per year will be 18. So once we have this 18. Now the next important part of this is you will remember that R1, R2 and R3 you have to repeat it 18 times for 2018 and 18 times for the year 2019. So if you combine this together, you'll get a total of 36 cells. Okay, so after you arrange these different variables in these fashions, I prefer you always start with the number of replicates. So remember just now we have calculated the total number of cells required per year is 18, right? So R1, R2, R3, this is one time, and then again 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 cells. Okay, 2018 from beginning till end you'll find total of 18 number of cells. From there it is much easier now. For the first year, since we calculated for 2018, first let us fill these 18 cells with 2018. Okay, so in this particular year, in our hypothetical study, the two seasons selected for the study are winter season and monsoon season. So these 18 cells can be now divided into two halves. So the first 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 will be for winter season, mark it this way. And the last 9 cells will be for monsoon season. This is the purpose of benefits derived if you calculate the number of cells first. Now, for sampling station. As we already know, in our hypothetical study, we have 3 selected sampling station, that is S1, S2 or S3. And each of these sampling station will have 3 replicate, that is R1, R2 and R3. So therefore, the first set of R1, R2, R3 will be for S1. So therefore you type here S1. Then the second set of R1, R2, R3 will be for S2. So therefore you have to type here S2. And then the third set of R1, R2, R3 will be for S3. So we type here S3. So with this, the winter season will be completed, right? So now water samples are collected from 3 different sampling stations. So similarly for monsoon season of 2018. So the first set of R1, R2, R3 for monsoon season will be for S1, and the second set of R1, R2, R3 will be S2, and the third set of R1, R2, R3 will be for sampling station 3. So with this, now we have completed for the monsoon season as well. Now, following the same procedures, you can repeat these steps for the year 2019. Or you can copy from the sheet of 2018 and paste it in 2019 sheet. And change only the year into 2019. After this, the next step is entering of the analytical data of various selected water parameters in these different cells. So how to enter the data in one go? Remember these are the data of 2018, right? So now these data are here. So how to copy this data and copy and paste it in that sheet? So the easiest way is just by, you see these empty cells here. Just highlight these empty cells and then give a right click and delete the entire row and click entire row. Okay, I'll get this. So since we are not going to need this, since it's already given in here, so this also, these cells also will delete this too as well. Entire row delete. Okay, so now I'll get only R1, R2, R3 data. See, Now you see that these are the data for winter season of 2018. So similarly for monsoon season, so these cells here will delete them all. Now see, we have got all the R1, R2, R3 data. If you count from here to here, you will find that the total number of cells will be 18. So now with simply you just have to do is highlight these values here, the blue values, copy them, and then go to that sheet where you're preparing for SPSS format and go to paste spatial and value. These are your 2018 water quality parameters. See, now everything fits within this cell. See, so this is the purpose of why I told you to do the calculation of number of cells required for each year. So in the same manner, you can repeat the same process for your 2019 data. So after repeating the same procedures, now you'll have these data marked in red color as the data for the year 2019. Now, once you have these data arranged in this format, then the water quality data for the year 2018 and the water quality data for the year 2019 are ready for transfer into an SPSS software. After we completed these steps, we will now move on to the next stage, that is the second step, which is entering the data into SPSS. But before that, first install SPSS in your system, and once you install, you can double click at the SPSS icon in your desktop. You will see the SPSS window popped up. In addition, if you observe carefully, you'll see that SPSS have two windows. One is called data view window and the other is called variable view window. Where in data view window, you'll be able to see the data arranged according to SPSS language, whereas in the variable view window, you'll be entering the correct coding or setting for different variables involved within your study. So now first let's work with the variable view window first. So as you already know, data will be functional for analysis only after the variables have been properly defined, because we cannot just copy and paste these data directly into SPSS data view window. Okay, because if you do so, if when you try to analyze, you will not be, the SPSS software will not be able to do the analysis. Therefore, variables have to be properly defined before the analysis is carried out. And then only a smooth analysis of any selected inferential statistics can be carried out. So in this window, the first variable in our study, what should it be? It should be the year. So you have to type here year, Y-E-A-R. Yeah. So once you type year, you just click in the next column, you'll see that automatically all this will pop up. So for most of the variables, you see that there's not much changes required here. Okay, except in few places. Okay, let's go one by one. Okay, year is done. Numeric, if you click here, you'll see this. Let it be as it is. Width is the length of the characters. Decimal here refers to the how many numbers after decimal. And the next variables here is written as label, refer to how do you want to see it when the data have been analyzed. You can write as here. Now values here you'll see none. Okay, but here is very important part that you need to know or to remember. First, you see that here none, you see there are three dots here. Just click here once. remember I told you earlier that if you copy and paste the values from the Microsoft Excel sheet directly into SPSS, you will not be able to process or to do any analysis, because SPSS will not be able to understand some of the variables. Therefore, some component of the variables need to be converted in terms of SPSS language. Like for year, how many years is a study conducted? For 2 years, right? So since we have conducted for 2 years, so what we can do here, so for let's say the first year here, for value just type 1 and label it for the year 2018. Okay, then you just have to add, click add, and see 1 is equal to 18. And for the second year, which is 2, value will be 2, label is at 2019. Okay, so now you see, this is what I was telling you about SPSS language, because if you keep this value 2018 in a data view window, you'll not be able to do any further analysis. Therefore, you have to change it in terms of SPSS language. So 2018 here will be known as 1, and 2019 will be known as 2. Just click OK. So once you've done this, then SPSS will understand now 1 will be 2018, 2 will be 2019. So here you can keep it as it is, and for measures you can keep it as nominal or ordinal, but I prefer to keep it ordinal because 2018 comes first and followed by 2018. So I'll keep it as ordinal. So you can also keep it as nominal. Okay. So once you have changed this, go to that Excel sheet which you prepared earlier. Open the Excel sheet. Remember this? See, just now we have written 1. 2018 will be written known as 1. So you have to change this in this 2018 into 1. Similarly, okay, for the year 2019, remove it and then you'll keep it as 2. Okay, so because in terms of SPSS, 2 will be for the year, it will be known as 2019. You get it? Now once you're done with this part, now next is, what is the next variables in our study, which is the season of sampling. So SEASO, season will be the next variable. Let it be this way. Here you can write the label as season. Okay, now we have how many seasons in our study? In our study we have 2 seasons. So one is winter season, the other is monsoon season. So for similarly, for the value 1 here, now here for 1 it will mean for winter. I just add it. And value 2 will be for monsoon season. See, now in this way, now whenever you say winter season, in term of SPSS it will be known as 1. When you say monsoon season, it will be known as 2 in term of SPSS. So you keep it this way. Okay, so here for the scale you can keep it as nominal. Okay, now since you have changed this, see, 1 for winter, 2 for monsoon. Now you have to again change the data in Microsoft Excel sheet as well. So winter will be written as 1. And for monsoon, it will be 2. Okay. Similarly, you have to change this for that of the year 2019. So for winter, it will be 1. So if it is 1, then all the winter will be replaced by 1. And for monsoon season, so all the word monsoon season will be replaced by 2. Okay. So now with this, we have changed the year and season as per SPSS language. Okay. Next, we have the sampling station. So you can write here station, stations. So now you just click here and automatically this will come up, and then you again type a station. Okay. Now in our hypothetical study, how many sampling station we have? I think you still remember, it's 3, right? So 1 is for sampling station 1, which is S1. Add it. 2 is for sampling station 2. added 3 is for sampling station 3. So now S1 will have to be replaced by 1, S2 by 2, S3 by 3. Okay. Now here, so you can keep it as nominal. Okay. Not as, yeah, you can keep it as ordinal as well if you want to. So since I have changed this value here, check again, 1 for S1, 2 for S2, 3 for S3. I have to change the values in Excel sheet as well. So 18 first, see, so S1 will be 1, right? S2 will be replaced by 2, S3 will be replaced by 3. Again for S1 will be replaced by 1. I'm replacing all S1 by 1 and I'm replacing S2 with 2 and S3 with 3. Okay, so since this will be the same for 2019, so I'll just copy it from here and paste it here. So all the S1 will be replaced by 1, S2 by 2, S3 by 3. So you'll get this in terms of SPSS language. Alright, then next, go back to your SPSS solver. Now we have the next variable, which is replicate. Okay, so you click here to the next column, you'll get immediately. You can write here replicates, replicates, replicate. And again here we have 3 replicates, right? One will be for R1, added. Then 2 will be for R2, added. 3 will be for replaced by R3. And see, 1 will be replaced by R1 will be replaced by 1, R2 will be replaced by 2, R3 will be replaced by 3. Tick OK. And in the same manner, this one also you can just keep it as nominal. Okay. Then go back to your Excel sheet, and R1 just now will be replaced by what? 1, right? R2 will be replaced by 2, R3 will be replaced by 3. So for all the R1, R2, R3, you have to replace it by 1, 2 and 3 respectively. See, now it will be like this. Now similarly, you can copy this from 2018 sheet and paste it in the 2019 sheet. Now we'll fill for the other variables, which are the parameters selected in our hypothetical study. And the first parameters selected is pH. I click it here. So again, in label type pH, this value to leave it as it is. So however, here you have 3 options: scale, ordinal and nominal. So you have to click scale because you'll be getting the reading of the pH of water from different sampling stations. So it has to be scale. So similarly, in the same pattern, you repeat for the other parameters such as dissolved oxygen. Again, here you also can type dissolved oxygen, and here it should be none. Okay, and the reading should be scale again. And next parameter, biological oxygen demand. For label, you also type as BOD, and it should be the same in scale. Then you have total hardness. You can type here and keep this as it is. And your next parameter is calcium. So you can type here. Similarly, you repeat for magnesium, conductivity, total dissolved solids, and turbidity. Once you have reached this stage, then you have inserted each and every variables that has been incorporated in our hypothetical study. Now you can click in your data view window and you'll see that the variables are arranged here. You can see it here, starting with year, season, station, replicates, pH, DO, BOD, total hardness, calcium, magnesium, electrical conductivity, total dissolved solids, and turbidity. So once you have arranged everything properly in a variable view window, then your data view window will be appearing in this way. So now next to do is open the Excel sheet where your data is. Since all these, you see now all these values here or the data here are or has been converted in terms of SPSS. So what you can do now is you can just copy them from here and go to your SPSS data view window and if I right click and paste. So you see that all your data will be appearing here. And this will be one, you already know one mean 2018, right? So again, as with the same thing, you go back to that Excel sheet and open your 2019 data. Now you see that all this data here, which are in red, copy them, copy, open, go back to SPSS data view window, and in the next, remember I told you to calculate how many cells for each year. See, 1 till 18 is for the first year. Now the second year will be from 19 up to 36. See, this is the purpose and the advantage if you do the calculation finding the number of cells required throughout the study period. So which means that we have filled all the 36 cells. We don't go less or more than that. So which means data entry is perfect. All right. So this is your data in SPSS. So once you have completed this stage, so now your data are ready to carry out any selected inferential statistics depending on the requirement of study. Okay, so this is how you enter the water quality data in SPSS. So I believe this tutorial will be of great help to those who are in need of help of how to enter the water quality data in SPSS. And if you find this video helpful, please kindly like, share, and do subscribe to my channel. So thank you very much once again, and God blessed.